Welcome back to The Explainer. Today, we are rolling up our sleeves and diving headfirst into one of the absolute cornerstones of modern physics. We're going to solve Einstein's famous time dilation formula. So, what do you think? Are you ready for this? We are about to tackle a concept that literally bent our understanding of reality. It looks intimidating, it sounds incredibly complex, and together, right now, we're going to solve it.
So, let's get into it. First up, we need to set the stage. In this section, we're just going to lay out the scientific challenge that our source material has handed us.
And here is our mission should we choose to accept it. It sounds simple enough. Solve for t. The goal is to take this massive equation and isolate that one single variable and, wow, here is the beast itself. I mean, just look at this thing. You've got variables, you've got a fraction, you've got a square root, you've got exponents. It's the whole shebang. And our job is to wrestle all of that to get that little t all by its lonesome on one side of the equal sign. Okay, but before we can even dream of solving this thing, we have to know what we're working with, right? Any good problem solver knows you have to understand the tools before you can start building. So let's break this formula down piece by piece.
First up is dilated time. This is dilated time. Basically, it's the time that you, standing still on Earth, would measure as you watch a super fast spaceship zip by. And remember, this is the very variable we're supposed to be solving for. Then you've got t naught, that t with the little zero. This is proper time. So if t is your time back on Earth, t naught is the time that the astronaut inside that spaceship is actually experiencing. Now, v is a lot more straightforward. It's just velocity. How fast is that spaceship going? Simple as that. And finally, the big one, c. The absolute rock star of physics. It's the speed of light, the cosmic speed limit. It's the constant that everything else here is measured against. Okay, now we know all the players. All right, deep breath. This is it. The moment of truth. We know the mission, we know the variables. It's time to follow the official procedure from our source and finally unlock this puzzle. And the instructions could not be more direct. Isolate t in the given equation. That is our one and only directive. So let's get ready. What's the first algebraic step we need to take? Step 1 is the equation is already solved for t. Hold on. What? Is that it? That's the only step? It just says it's already done? No way. There has to be a trick here, right? Okay, let's take a minute to process that. Welcome to section 4, the surprising solution. It seems the big reveal is a little different than any of us expected. Let's try to figure out what is really going on here. Let's look at this thing one more time. The exact same equation we started with. But this time, I want you to look really closely. Where is the t that we were supposed to solve for? Yeah, it's right there, on the left, already by itself.
So, if the entire goal was to isolate unt, and unt was isolated from the very beginning, what is the solution? What was the answer to this massive intellectual challenge we geared ourselves up for?
And there it is, the punchline. There is no problem to solve. The equation, as it was given to us in the very beginning, is the solution. Our entire journey was based on a question that didn't need an answer because it was staring us in the face the whole time. So, was this all just some big joke? Well, not quite. This whole exercise brings us to the real point. The real lesson here isn't about physics. It's about critical thinking. It's about how we approach a problem and where we get our information from to begin with. So here are the real takeaways. First, always, and I mean always, make sure you understand the question before you waste energy trying to find an answer. Second, don't go looking for complexity that isn't there. Sometimes the simplest answer really is the right one. But here's the real kicker. This entire problem was generated by an AI. It could assemble the parts, it could define the terms, but it couldn't understand what it was actually asking. It shows us that AI is an incredible tool, no doubt, but it's a tool that is very much a work in progress. And I want to leave you with this final thought, which is actually a footnote from the AI model that created our little puzzle. Generative AI is experimental. I mean, could there be a more perfect summary? It's a reminder to all of us, stay curious, absolutely, but also stay critical. And never forget that sometimes the most complex problem you're facing might have already been solved. Thanks for joining me.